Good morning, my dear students. Welcome to Teacher Jovi's classroom. Our topic today is evaluating functions. Let's look at our objectives. After going through this lesson video, you are expected to, number 1, recall the process of substitution. Number 2, identify the various types of functions. And number 3, evaluate functions. Before we proceed to our discussion, I want you to go through this preliminary test. Get a sheet of paper and a pen and participate in this short quiz. Write the letter that represents your answer. Now don't worry if you don't know some of the topics yet. This is just a test about your prior knowledge of our lesson. So please take note that the answers will be given right after each item. So be ready with your answers just before the answer will be given by the teacher. Okay, so let's start. So here's number 1. Which of the following is a polynomial function? I'm not going to read to you the choices. I'm giving you a short time to choose your answer. Okay, I guess you're ready with your answer. Okay, very good. The answer is letter A. Okay, so let's look at number 2. What kind of function is being illustrated by this given function here? A, is it a rational function? B, a constant function? C, greatest integer function? Or letter D, absolute value function? Okay, I guess you got it correctly. The correct answer is letter D, the absolute value function. Okay, so here's number 3. Give the value of the function m of x equals 9x minus 2 when x equals negative 3. A, is it 25? B, negative 27? C, negative 25? Or D, negative 29? I'm giving you 10 seconds to answer this. Alright, let us check. I guess this one is still very easy for you. So, the answer is letter D, negative 29. Here's number 4. Evaluate h of x equals 5x squared minus 8x plus 12, given that x is equal to 5. So, is it A, 22, B, 145, C, 97, or D, negative 3? Okay, again, I'm giving you 10 seconds to do this. Or if you need more time, you can pause the video and take your time answering. Okay, I guess you're done. Okay. So the answer is letter C. I guess you're very good. So here's the last question for our preliminary test. If f of x equals 5x minus 4, what is f of 4? Letter A, 16, letter B, 4, letter C, 5, and letter D, 2. I'm giving you 10 seconds to answer this. Now again, if you think you need more time, then you can pause the video and take your time answering. Okay, I guess you're ready with your answer. So let us check. The correct answer is letter B, and that is 4. Okay, so congratulations. I think you did very well in participating in this test. I want you to total your scores and comment down there in the comment section your score. Now don't be afraid, and no shaming please for those who got high scores. Congratulations. For those who got a bit lower scores, now don't worry, that means you have room to learn for today's lesson. Okay, so let us proceed now. So here we go. So how do we evaluate functions? Okay, so let's look at the steps. Number one, we replace each letter in the expression with the assigned value. And number two, we perform the operations in the expression using the correct order of operations. Okay, let us look at this example. Find the value of f of x equals 3x minus 5 if the value of x is 2. Again, find the value of f of x equals 3x minus 5 if the value of x is 2. So let's have this. We will replace x with 2 because the value of x is 2. So we have, going back to the original equation, we have f of x equals 3x minus 5. The x is here we will replace with 2. Thus we have f of 2 equals 3 times 2 equals 5. So x there we replace with 2. And then we have 3 times 2 equals 6. And then we bring down negative 5. Then we have 6 minus 5 is equal to 1. Therefore, f of 2 is equal to 1. Okay? So, here's another example. G of d equals 2d cubed plus 4. And we're supposed to find g of negative 2. Okay? For our solution, we replace d with negative 2. Okay, we copy the given function. G of d is equal to 2d cubed plus 4. And then next, we replace d with negative 2, or we substitute d with negative 2. So there you go. You have replaced the d with negative 2. So you have g of negative 2 equals 2 times negative 2 cubed plus 4. Okay. And now we try to simplify the right side. So we start with negative 2 cubed there. Negative 2 cubed means we multiply negative 2 to itself 3 times. Okay, so that's negative 2 times negative 2. That's positive 4 times negative 2 again. So that is negative 8. Therefore, you have here, for this part, we have 2 times negative 8 there. Negative 2 cubed is negative 8. Okay. We brought down 2 there. And then we have here 4. Bring it down. Okay. And then multiplying 2 times negative 8, that's negative 16. And then we bring down 4. Okay. And then negative 16 plus 4, that gives us negative 12. Therefore, we have g of negative 2 equals negative 12. Before we continue with our examples, let us recall the types of functions that I guess you have met when you were still in your lower grades. Okay, so the first type that we have is the constant function. A constant function is a function that has the same output value no matter what your input value is. Because of this, a constant function has the form f of x equals b, where b is a constant, a single value that does not change. So you have there under example, you have y equals 7. Or in other forms, you may have f of x equals 7. Whatever x value, y will always be 7. Or f of x will always be 7. You have there another example, you have g of x equals 25. Since it's a constant function, g of 1 is also 25, and g of negative 4 will also be 25. So that's the constant function. There's only one value, the constant. Okay? And we also have the identity function. The identity function is a function which returns the same value which was used as its argument. In other words, the identity function is the function f of x is equal to x for all values of x. Okay, we have there f of 2 under example. F of 2 is equal to negative 2. What do you think is the answer for g of negative 5? if this is an identity function, g of negative 5 will be negative 5. And the other one there, you have there, the covered one is d of t. Okay? So for any t there, the value will always be t because it is a constant function. Oh, sorry, it is an identity function, not a constant function, identity. Okay? Whatever x you used, that will also be the value of the y. That is identity function. Okay? Let's proceed to the third one. We call it the polynomial function. I guess this one is very familiar. Now, under polynomial function, we have three categories here. We have the linear function. The linear function is a polynomial function with degree 1. Okay? It is in the form y is equal to mx plus b. And you have there an example, y equals 2x plus 5. Okay? Or you may have y equals 3x minus 2. Okay? So the exponent of x is just 1. Okay? That's linear function. By the way, it's called linear because the graph is a line. The second one, we have the quadratic function. If the degree of the polynomial function is 2, that means the highest exponent is 2. Then it is a quadratic function. It is expressed as y equals ax squared plus bx plus c, where a is not equal to 0. And a, b, and c are constant, and x is a variable. You have there under example, you have y is equal to 3x squared plus 2x plus 5. And you also have cubic function. A cubic function is a polynomial of degree 3 and can be denoted by f of x equals ax cubed plus bx squared plus cx plus d, where a should not be 0, and a, b, and c and d are constant, and x is a variable. So you have here the example. I'm sorry, it's covered by my video. So y is equal to 5x cubed plus whatever follows there, as long as the exponent, the highest exponent for x should be 3 because it is a cubic function. Okay, so these are examples of the polynomial functions. We also have what we call the power function. A power function is a function in the form y is equal to ax raised to b, where b is any constant number. Many of our parent functions, such as linear functions and quadratic functions, are in fact power functions. So look under example, you have there f of x is equal to 8x raised to 5. Okay. We also have the rational function. Okay. A rational function is any function which can be represented by a rational fraction, say p of x over q of x, in which the numerator, or p of x, yung upper part, and the denominator, q of x, that is the lower one, no, are polynomial functions of x, and q of x is not equal to 0. Otherwise, the function becomes undefined. Okay? So we have there under example, f of x is equal to x squared minus 3x plus 2 all over x squared minus 4. And there should be a limitation to that x should not be equal to plus or minus 2. Okay. And then we still have other examples of functions here, or types of functions. We have exponential functions. Okay. These are functions of the form y is equal to a, b raised to x, okay, where x is in an exponent, and a and b are constants. Note that only b is raised to the power of x and not a. If the base b is greater than 1, then the result is exponential growth. Okay. Under example, you have y is equal to 2 raised to x. Okay. So take note, guys, that the exponent here is x. Okay. Compared to the polynomial functions like the quadratic functions and the cubic functions. x is a base and the real number is an exponent, dito po baliktad na, you have your x as an exponent. So it's called exponential function. And we also have the logarithmic function. Okay, if you see the log or log in your calculator, okay, that represents logarithm. Okay, and we have logarithmic functions. These are inverses of exponential functions, and any exponential function can be expressed in logarithmic form. Logarithms are very useful in permitting us to work with large numbers while manipulating numbers of a much more manageable size. It is written in the form y equals logarithm to the base b of x. X should be greater than 0, where b greater than 0, and b should not be equal to 1. So under example, you have there y equals logarithm of 49 to the base 7. Okay, don't worry guys, you will meet all these functions at the latter part of the quarter. Okay, so this is just an introductory part. Okay, so we have the exponential and the logarithm. So let's have the last two types of functions. We have the absolute value function. If you remember the absolute value class, it is represented by two bars. Okay, so the absolute value of any number c is represented by the absolute value of c. Okay, and for a function, it is defined by f of x is equal to the absolute value of x. Okay, simply put, guys, the absolute value renders a number its positive value. For example, the absolute value of 2 is equal to 2, and the absolute value of negative 2 is also equal to 2. Okay, so here's an example of absolute value function. Y is equal to the absolute value of x minus 4 plus 2. Okay, and let's have the last one, the greatest integer function. Okay, the greatest integer is represented by double bars. Okay, or it's like a double absolute value. So you have the notation here. In our example, f of x is equal to this one, the greatest integer function, x plus 1. Okay, so we have here x inside or in between the two double bars, which is represented, or a notation. This is the notation for the greatest integer function. Now, the greatest integer function, it rounds off the real number to the integer that's less than the number. We will have an example of this later. Okay, let's continue with our examples. Okay, let us evaluate the functions again. So we have here a polynomial. P of x is equal to 3x squared minus 2x plus 5. We are asked to find p of 0 and p of negative 1. So let's look at this. Okay, we will start with p of 0. So we will copy the original equation. Okay, as we have done a while ago in the first examples. Okay, so we get the equation, the given equation, and then we substitute 0. We substitute 0 for this one. We substitute 0 to all the x's. So we have there x replaced with 0. Okay, so here x here is replaced with 0 and x replaced with 0. Okay, and then we apply the operations. Okay, so we have 0 squared is 0 times 3, that gives you 0. 2 times 0 is another 0, so that's minus 0, and then we bring down 5. So 0 minus 0 is 0, of course, and then we have there 5. Therefore, we are left with p of 0 equals 5. Okay, let's look at the other one, at p of negative 1. So again, we get the actual or the original equation or original function. P of x equals 3x squared minus 2x plus 5. And we do the process. We substitute negative 1 in all the x's. So there you go with the blue color. So x here is replaced with negative 1 there. Okay, and there, negative 1. So you have now p of negative 1 equals 3 times negative 1 squared minus 2 times negative 1 and then plus 5. Okay, applying the operations, we start with squared here. So negative 1 squared becomes 1. Okay, and then there, negative 2 times negative 1, negative 2 times negative 1 is 2, and then we bring down 5 there. Okay, and then again, we simplify this. We have 3 times 1 is 3, and then we bring down 2, and then there 5. And combining all this, we have 3 plus 2 plus 5. That gives us 10. Therefore, p of negative 1 equals 10. Okay, let's look at example number 4. Evaluate the function. Again, we have here an absolute value function. Very good. So find the value when the function of the function when x is equal to 2. Okay, so again we replace x with 2, or we substitute 2 to the x's in the function. So we have there, we copied the original function, and then we substitute the value of x. We have 2, we substitute to x, so there you go. So x here is replaced with 2. Okay, there. So we now have f of x equals the absolute value of 2 minus 10. Okay, and working at the numbers inside the absolute value, 2 minus 10 equals negative 8. So you have there the absolute value of negative 8. And again, as I have told you earlier, no, an absolute value renders the positive value of the number. Okay, so when you apply the absolute value to negative 8, that gives you positive 8. Therefore, f of negative 2 is equal to positive 8. Okay, let us look at, here's our next example. What kind of function is this? Okay, very good. You got it correctly. This is the greatest integer function. Okay, so find the value of the function when x is equal to 3.4. Okay, so for our solution, we will substitute 3.4 to the given equation or function. Okay, so we have, okay, the original function, and then we replace the x's with 3.4. So we have g at 3.4 equals the greatest integer function of 3.4 minus 7. Okay, so you notice x is replaced with 3.4, x with 3.4 here. Okay, and applying the rule for the greatest integer function. So when you say 3.4, we have to get the lower integer. Okay, so we have 3.4. What's the lower integer here? Is between, you have there 3 and the next number there, or integer, there will be 4. Okay, so therefore this one, the value of this greatest integer function here should be 3, and then bring down negative 7. Okay, and 3 minus negative 7 is correct, that's negative 4. Therefore, you have g at 3.4 is equal to negative 4. Okay, I hope you understand that well. And we have our last example. Okay, we have h of x is equal to 4x minus 7. And the question is, what is h at x minus 1? Okay, so look at this. Our supposed value for x becomes now x minus 1. So do not be confused with this, guys. You just have to substitute. Okay, so we substitute x minus 1 to x in the original function. Okay, so for our solution, we replace the x with x minus 1. Okay, so getting the original equation, we have there h of x equals 4x minus 7 taken from the original. Okay, and then we replace the x's here with x minus 1. Therefore, we have h times, or h of x minus 1 equals 4 times x minus 1, and then 7 minus 7 there, we bring it down there. Okay, so do not be confused, guys. Do not multiply this. This is a representation of the function, so we are not going to multiply this part. Okay, so we just have to multiply the right side, this. Okay, so we distribute 4 times x, we have 4x, and then 4 times negative 1, we have negative 4, and then we bring down negative 7 there. Okay, so simplifying this, we now have, okay, 4x, it has no similar term there, so we bring down 4x, and then we combine negative 4 and negative 7 there, so we have negative 11, and that gives us h of x minus 1 is equal to 4x minus 11. Now, do not expect an exact value or a constant value here, class, because what we have here is x minus 1. Okay, so we expect that we still have x in our final answer. Okay, so I hope you got this correctly. You can go back to the video in order to understand it very well. It's your turn now. So get your module and answer the exercises assigned to you in your weekly home learning plan. So thank you and have a great day, class.